Now we're going to use corresponding sides and angles to develop congruent statements, to read them, and to actually solve for some missing sides and angles in simple problems. So congruent figures have the same size and the same shape. That's what congruent means. Two polygons are congruent if and only if their corresponding angles and sides are congruent. So all the angles have to match and all of the sides have to match. If all the angles don't match, then it's not congruent. If all of the sides don't match, it's not congruent when I say match from one polygon to the other. The congruent statement, which is something we're going to be making, shows you which two polygons are congruent. And one thing I should say, it says by listing the names of both polygons with a congruent symbol between them, those points that they use, the vertices, they have to be in matching order. So if you're listening to me now, write that down. You'll miss it if you're not listening. Okay, so let's go ahead and do an example. I know that CA is congruent to HI, PA is congruent to TI, and angle A is congruent to angle I. So I'm going to use this to complete the congruent statement for two triangles. Well, the first thing we should do is go ahead and draw a triangle. I personally like drawing an equilateral triangle, so I'm not married to any particular measure. I don't know which angle is the biggest and which angle is the smallest, so I tend to draw them this way. Then you're going to want to make a matching congruent triangle. And after you do that, I'm going to say CA, so I'm going to label one point A and one point C. Well, A goes with I and C goes with H, so you see how I put H and I there, and I'm going to put them on the other triangle. And they see how they're matching. C goes with H, A goes with I. Then I also know that PA goes with TI. So PA would be this side. That means that T would go with this point P, and I put it on the other triangle. So triangle CAP goes with triangle HIT. I can't do THI or ITH or HTI. It has to be in the order that goes with CAP, so it's HIT. We can also use this to find missing angles and sides. So if the polygons are congruent, you can use this corresponding angle or side to find the missing angle or side, since you know they have to match. You set the two values to be equal since they are congruent. So we'll look at an example here where I have triangle Jen and triangle Amy. Well, the congruent statement tells me what vertice goes with what vertice. So J down here, which is a right angle, goes with with A. See, J goes with A. So right here, that has to be a right angle. Then E, which is 57 degrees, goes with M. So I can say 57 degrees here goes with the M here. That has to be 57. Then I know N goes with Y. But I don't know the angle measures yet. But I do know this is a right triangle, and 57 and this angle are complementary. They have to add up to 90. So I solve it. I set up 57 plus N is 90 and solve it, and I get 33 degrees. So these two angles are congruent, and they both measure 33 degrees. Finally, I can fill in the missing sides. I know that's 5, and that's 5. And then I also know I have my hypotenuse already, the 13. And finally, the last side is 12. So for further reflection, how do we know how to set up congruent polygons given congruent sides and angles? Make sure that the corresponding parts match. And then how do we use the congruent statement to mark congruent angles and sides? You notice how I went in order, going with the first vertex goes with the first vertex, and then the second vertex goes with the second vertex, and etc.